Well, good morning, everyone. Today we're here to do the AP Calculus B final. This is the first semester of the Calculus BC, and we are on question 14. As a reminder, this is meant to be a no calculator section, so you won't see use of any calculator in this video, and we're going to get started. This video should cover questions 14 through 19. So starting with question 14, we have find the derivative dy dx if y is equal to the integral expression from 0 to cotangent x cosecant squared t dt. If we start off with the expression y equals the integral, then we just need to take the derivative with respect to the left side and the right side. So you'll see that here with this expression, dy dx over here on the left and dy dx over here on the right as well. That just means we're taking both derivatives with respect to x. Now the left side of this equation is not a problem. Dy dx is the derivative of y with respect to x. However, the right side is a little bit of a problem because we notice that the integral is in terms of t. So what we're going to do is we're going to take the derivative of the right side in terms of t first, and then we'll multiply by the derivative with respect to x. Notice that we have a mismatch here. This is d dx, and this is cotangent x. So what we're going to do is we're going to make a u substitution. We're going to say the variable u is at cotangent x, which means we need to multiply by du dx at the end of this so we can get our derivative with respect to x. And just as a reminder, u is going to be the same thing as cotangent x. So we're saying if u is cotangent x, then we take the derivative of the integral with respect to u first, and then we multiply by the derivative of u in terms of x. Which means, of course, we're just taking the derivative of cotangent x and multiplying that at the end. This is all great because if you take a look over here, since the upper limit now matches the variable of differentiation, which means this u here matches this u up here in the upper limit, and this lower limit here is now a constant, we can just substitute u into the integral. Remember, this is special rules because we're taking the derivative of an integral. You can't just take an integral and substitute it in there. It has to be the derivative of an integral. So that derivative is just cosecant squared of u. Now we're going to multiply by that by the derivative of cotangent x, and the derivative of cotangent x, well, that's just negative cosecant squared x. And now remember that u was the same thing as cotangent x. Well, if u is the same thing as cotangent x, then we can substitute this u over here in yellow, this one right here, we can substitute that with cotangent x. So now the expression reads the cosecant squared of cotangent x multiplied by negative cosecant x. Now, at this point, we'll just do a few cosmetic changes. Let's take that cosecant squared out of the brackets. Take that negative sign and put it negative, not negative sign, but negative sign. Let's move it to the outside. And then we don't need the parentheses around cosecant squared anymore. And there we go. The derivative of y with respect to x is negative cosecant squared of cotangent x multiplied by cosecant squared x. Using the commutative property, you can make that look a lot like the answer key. So negative cosecant squared x multiplied by the square of cosecant of cotangent x. Okay, let's move on. Let's take a look at this question 15 over here, where we evaluate the integral of sine t minus 5. This one shouldn't be that big of a problem. Let's just write our problem, or write it out. All we really need to do here is, since we have a subtraction, we just need to take the antiderivative of each one of those subtractands and then substitute. So the antiderivative of sine is negative cosine. And then the antiderivative of 5 is 5t. We'll do a substitution. Substituting pi over 2. And then substituting negative pi over 2. And then now we just evaluate. Then we'll do some simplification. And it does seem like I made a quick error. That lower limit was supposed to be negative pi over 2. So looking up over here, that should be a negative pi over 2. So should that one on the back end over there. That doesn't really affect the cosines, since cosine of negative pi over 2 is just 0. But it does affect this 5 pi over 2 here, since that should actually be negative 5 pi over 2. Kind of like that. So now we were just going to add this all together. We've got a, maybe we should simplify the negative signs before we do that. Inside here, we can just simplify that to positive 5 pi over 2. Kind of like that. And then we have negative 5 pi over 2 minus 5 pi over 2, which is equal to negative 10 pi over 2, or negative 5 pi. Sorry if that was a little bit confusing. Things happen like that. And let's move on then to our next problem, which is this one over here, number 16. We've got a pretty vague looking question, which we'll get to in 1 second, but the particle is moving with a velocity of 2t plus 3, and we're meant to find the distance traveled between t equals 2 and t equals 4. Now, the reason I say this is kind of vague is by now you've learned that there is total distance traveled and there's also displacement, and we're not quite sure which one is meant here. It could be displacement, it could be total distance traveled, but I think it's actually not going to matter, because when we analyze this, we're going to notice that the particle doesn't actually change direction. So we're going to start off by looking at this as though it was a total distance traveled problem. So for a total distance traveled problem, we need to figure out whether or not this particle, or whatever is traveling, we need to figure out if it changes direction. And to find those values of t where the particle does change direction, well, let's look at the velocity and try to figure out when does that velocity equal to 0. Setting 2t plus 3 equal to 0, really easily we can figure out that that happens when t is equal to negative 3 over 2. And if we're only looking for in between, where in between t equals 2 and t equals 2 and t equals 4, well then our particle isn't going to change direction in that interval. So the particle does not change direction, and for t between 2 and 4, displacement and total distance are the same thing. So we'll just find the integral from 2 to 4, and that will be the total distance traveled. So total distance is the integral from 2 to 4 of 2t plus 3. And so total distance is t squared plus 3t, evaluated from 2 to 4. We'll go ahead and evaluate at 4 and then evaluate it at 2. Then find the difference. First, we'll substitute 4. Then we'll substitute 2. Square. Multiply. Add. And then subtract. Okay, so our total distance looks to be 16, and we are ready to move on to our next problem. All right, number 17 says to find the general solution to the differential equation. So basically just a integral. Noticing that we have the word general solution here, that means that we just need to integrate and leave our solution with the constant c intact. So we're going to integrate both sides of our equality with respect to x. We've got a little bit of canceling we could do on the left side with those dx's. Most of the time you wouldn't even bother with that step and you would just naturally put a y there, but trying to be a little bit complete here. On the right side, we can separate that antiderivative into two different integrals. Again, after you have done integrals for a while, this actually becomes pretty, well, you wouldn't necessarily separate that out since you've had so much experience with this. I'm going to copy this and we'll go ahead and integrate each part here. Let's see, the antiderivative of dy, well, that's just y. And then the antiderivative of secant tangent, I believe that is secant x. We'll replace that with a secant x, and then this is where we're going to get our plus constant. And then the antiderivative of e to the 5x, if we can imagine doing our u substitution. In fact, let's just put it over here. We'll do our integral of secant x of e to the 5th x. And then we're going to do a u substitution where u is 5x. And if u is 5x, that means du is 5 multiplied by dx. Copying our integral again, we can replace this 5x in the power up here. We can replace that with a u, since u is the same thing as 5x. And over here with our dx, since du is 5 dx, we can replace that dx with a 1/5 of du. That doesn't look nice. 1/5 of du. Let's put that in parentheses, and yeah, that's great. 1/5 of du. So that's where the 1/5 comes from. When I take my antiderivative, that 1/5 is going to persist, and then we'll get the antiderivative of e to the u du is just e to the u, and of course plus constant, and that's equal to 1/5 e to the 5x. All right, so now we have that. I should be more correct and put a plus constant here. Now that I have that, I can change this to a 1/5 e to the 5x. And yeah, we're finished with this. It's hopefully a pretty simple problem, and let's take a look now at question number, what are we on, 18? Yeah, 18. A couple more to do for this video, and then we'll be, well, I'll move on to the next video. So let's see, number 18. Coming to think of it, since I was trying to do 5 for video, I think this actually is going to be our last one. 14 through 18 does sound like 5 problems. So let's see, we've got match this differential equation with the appropriate slope field. Now it probably helps if we zoom in a little bit on these. So let's go ahead and do that. Yeah, we do want to look at these slope fields really well. So noticing that I have both an x squared and a y squared here, one of the strategies which would probably be good to use here is just to kind of figure out where are all the places where the derivative is equal to 0. Let's highlight that in yellow. So if I'm taking a look at number 18, let's zoom in on 18. Take a look at 18. I see that all the derivatives are equal to 0 right along this diagonal right here, which I'm assuming is x equals y. Now right along there, all the derivatives, all the slopes in the slope field are horizontal, meaning they have a slope of 0. Taking a look at letter B, I say the same thing right along here. The slope is equal to 0. But I also see the same thing right over here. So that looks like whenever x equals y and whenever x equals negative y. Let's take a look at the other two slope fields. Where is the derivative equal to 0? Where is the slope equal to 0? So we got another one right here. We've got a horizontal line, and we got a horizontal line right over here. If I had to estimate, I would say that that happens when x equals 2 and, when y equals 2 and y equals negative 2. And this one right over here, where do I have horizontal slopes? And it looks like I have a horizontal slope all up and down this way. That's about it. So that means I have this derivative, the slope is equal to 0 whenever x equals 0. And then here we have a slope equals 0 whenever y is equal to 2 and negative 2. Here, letter B, it looks like we have the slope is equal to 0 when x, the absolute value of x is equal to the absolute value of y. And then for letter A, it looks like we have a slope equal to 0 whenever x is equal to y. Let's take a look here again, and which one of those best matches what I'm seeing in the differential equation. And this looks like whenever x and y are the same number, not necessarily the same sign, we're going to get a slope of 0. So to be clear, I'm looking here for when the slope is equal to 0, which means whenever dy dx is equal to 0, which means x squared minus y squared is equal to 0, which is the same as saying whenever x squared is equal to y squared. Now, hopefully that's enough for us to decide that the correct answer is B, but it's probably worth it for us to remember that in order to solve an equation like x squared equals y squared, we would take the absolute value. I personally think this is going a little bit far with the example, but who knows? We are going to need to take the square root of an x squared at some point. And just remember, if you're the person who's implementing that square root, if that square root's not written for you, you are obliged to put the absolute value. So that right there should solidify it. Our correct answer should be letter B. Let's draw a circle around our answer. And we are finished. So there we go. There's our question. Numbers 14 through 18. We'll see you on the next video.